So in the beginning of 4.6, we talked about cotangent and tangent. Okay, quick review. We said if you had y equals tangent, whatever bx minus c is, then to start, the amplitude is the absolute value of a. The a would be in front of the tangent. If it's positive, then tangent points up to the right and down to the left. If it was negative, it will flip the other way. The b leads to the period, but the period this time is pi over b. And then we take our bx minus c, whatever's inside those parentheses, if there's a parentheses, and if not, then just the bx. We set it equal to negative pi over 2, and then we set it equal to positive pi over 2 for tangent. What we get from there, we subtract the period from the one on the left. We add the period to the one on the right. That's our 4 asymptotes. So on our graphs, they would look something like this. And then we have to locate the point halfway between. And to do that, we add those 2 asymptotes, divide by 2 if it's not an obvious midpoint. And then I want to mark my quarter point and my 3/4 point for each one. And I would go down the amplitude and up the amplitude on the right. So down at the quarter point, up the 3/4 point. And then you draw your curves for tangent. And then for cotangents, it's almost the same. The difference is, again, it would be a cotangent bx minus c. The difference, these are the same, okay? The difference comes here. So I set bx minus c equal to 0 and bx minus c equal to pi for cotangent, because that's where cotangent's undefined. And then I do the same thing, subtract the period from the one on the left, add the period to the one on the right, and then set up your asymptotes. Again, they would be 4 vertical lines. Find the point halfway between. The difference, the second difference between cotangent and tangent is that cotangent goes up to the left and down to the right. So at your quarter point, you're at positive amplitude. At your 3/4 point, you're at negative amplitude. And then for both of these, if you added d to the end, so if there was a vertical shift, if it's positive, we're going to take everything and shift it up that many places. If it was negative, we're take that many and shift it down. Questions on anything related to tangent and cotangent? All right, so for here, the A was 2, which is positive, so that's your amplitude. The B is 1. The period was pi over 1, or pi. And then I said x plus pi over 4 equal to negative pi over 2, and x plus pi over 4 equal to positive pi over 2. Solve those, and I got the middle two asymptotes, which were negative, x equals negative 3 pi over 4, and x equals positive pi over 4. From the one on the left, I subtracted the period, and you should get x equals negative 7 pi over 4. From the one on the right, add the period, and you get x equals 5 pi over 4. So when I set it up, I added in my asymptotes at negative 7 pi over 4, negative 3 pi over 4, pi over 4, and 5 pi over 4. And then you want to find the points midway between. So for each of those, I added the two asymptotes divided by 2, and I got a midpoint, which is going to be a 0, at negative 5 pi over 4, negative pi over 4, and 3 pi over 4. I plotted those points. And then a quarter of the way in, this is cotangent, so a quarter of the way in you're going up, and 3/4 you're going down, whatever the A is, or your amplitude. So a quarter of the way in, I went up to 2, 3/4 I went down to 2, to negative 2, and then I drew my curve. Questions on cotangent or tangent before we move on? All right, so cosecant is next. Cosecant is the reciprocal of what function? Sine. So to graph cosecant, you actually have to first graph sine, and then wherever there's an intercept, you'll get an asymptote, because think about it, if sine was 0, then cosecant would be undefined. That means asymptote. And then wherever there's a peak, like a hill, you would bounce your parabola off it. Wherever there's that valley, you would bounce your parabola off it going in the other direction. So this original curve is actually sine. And then there's a curve pointing up on every maximum on that curve, and a parabola pointing down on every minimum of that curve. And then the asymptotes go through where the x-intercepts would have been, because they would then become zeros. So the actual graph of cosecant does not involve sine. Like sine would actually not be part of it. However, you need that to get to it. So if you wanted to draw it, make it dashed like they did, that's fine. If you want to draw it and erase it, that's fine too. But you'll have to first graph sine, and then from that bounce off of it. So it has the same properties as sine. Period is 2 pi. Domain is all the real numbers except on the integrals of pi, because that's where the asymptotes would be. The range is going to be values where y is greater than or equal to, or less than or equal to negative 1, or greater than or equal to 1, because they're bouncing off of those. The vertical asymptotes occur at those integral multiples of pi, meaning pi, 2 pi, 3 pi, 4 pi, like that. And it's also an odd function. The graph of secant is based on cosine. So if you zoom in on this, you'll see that this curve right here is actually cosine. Everywhere there's an intercept is a asymptote. And everywhere there's a maximum, there's a parabola pointing up. Everywhere there's a minimum, there's a parabola pointing down. So same qualities of a secant, of the cosecant. The period is 2 pi. The domain is all real numbers except odd multiples of pi over 2, because this is based on cosine. That's where it would be 0. The range is the same. It'd be greater than or equal to 1, or less than or equal to negative 1. And the vertical asymptotes occur at the odd multiples of pi over 2, and it's an even function. So remember that cosine and secant are even functions. So this is just some variations. If I take and I stretch out my period, you're going to see more, or if you stretch out your period, you'll see less parabolas in that section than you normally would. If you shrink your period, then you're going to see more parabolas. The second one also has an amplitude change, so you're going up to 2 and down to negative 2. So everything that we would do with sine and cosine, we're going to do with secant and cosecant. There's just that extra step of adding in the asymptotes and the curves. All right, so this actually says first graph y equals sine of 2x, and then graph its reciprocal function. Just realize that on the test it would just say graph y equals cosecant 2x. It's not going to tell you what its reciprocal function is. So I would start with the sine curve. I start the way we did. A is 1, which means the amplitude is 1. The B is 2, and what is the period for sine? 2 pi over B, so this would be 2 pi over 2. This is pi. Then I'd find my quarter point, my half point, and my 3/4 point. Pi over 4, pi over 2, and 3 pi over 4. And then the first one is 0, the last one is pi, and there's no phase shift, so I start there. I plot my 0, I plot my pi over 4, my pi over 2, my 3 pi over 4, and pi. So 5 key points. My amplitude is 1, so I'm going up 1 and down 1, and it's cosecant, which means I'm going to first graph sine. So I would go to 0, up to 1, down to 0, -1 to 0. So that would be your sine curve. Everybody with me so far? So everywhere there's an x-intercept, if I flip that 0, I'd get undefined, which means those are going to be my asymptotes. And then the curves bounce off of your max and min points. I said it when I did, we talked about tangent and cotangent, but it's the same expectation for secant and cosecant. You need 4 asymptotes and 3 curves, which means I need to add on another half period on this one. You can either add it to the right or add it to the left. I don't care which direction. You don't have to find exact points. You just want to space them out the same. So if I add it to the right, I would have another midpoint here, and then this would actually be 3 pi over 2. But again, as long as you just eyeball it, you'll be fine. The sine curve would have continued to go up to 1 and back down, which means my other curve would look like that. So for your final answer, you need, highlighter. 1, 2, 3, 4 asymptotes and 1, 2, 3 curves. And again, the question on your test is not going to say graph y equals 2 sine of 2x and then graph its reciprocal function. It's just going to say y equals cosecant of 2x. And you've got to know sine is the one you have to graph first. Questions on that one? All right, so same setup here. First, it's telling you what to graph. And again, I want to stress it on your test. It would say y equals 2 secant 2 pi x, and you have to know that means first graph the cosine and then the reciprocal function. So this time my amplitude or my A is 2, which means that's the amplitude. What's the B? 2 pi, which means the period is 2 pi over 2 pi, which is 1. There's no phase shift, but if there was, I'd have to account for the phase shift. There's no vertical shift, but if there was, I'd have to account for the vertical shift. So just realize all of that can be part of it. So then my quarter point, half point, 3/4 point would be 1/4, 1/2, 3/4. First point is 0, last point's the period, which is 1. Go to your graph. First one 0, 1/4, 1/2, 3/4, 1. Amplitude is 2. And we're graphing cosine first, which means I'd start at the amplitude, come down, down, up, up, draw your curve. How many asymptotes is that going to give you? How many x-intercepts are there? 2. I need 4. Okay, so with cosine, it's easiest just to drop the curves down on either side. So that would be a -1/4, and this would be a 1 1/4. But again, I don't need those exact marks. I just need you to eyeball the spacing. Then draw through your asymptotes. And add on your curves. They bounce off the max and mins. So the secant curve is the 4 asymptotes and the 3 parabolas. So the good thing is that in doing this section, you're forced to review sine and cosine. Again, I said that's why I kept stressing how important it is to have sine and cosine known well, because you have to use those for these. So on the test, you're going to have 3 graphs. You're either going to have a sine or a cosine. You're either going to have a tangent or a cotangent. And then if you have a sine, you're going to have a secant because that forces cosine. And if you have a cosine, you're going to have to do cosecant because that forces sine. So you need to know, obviously, all 6 because you don't know which one you're going to get. But you will get, there's 3 of them that's going to be, that will be on your test. So this is just like the overview of all of them, right? We started with sine. With sine, we'd start at 0. We go up to the amplitude, back down to 0, back up to the amplitude. The period is 2 pi over b. We find the quarter point, the half point, the 3/4 point, and then the final is the period. We look for phase shifts, we look for vertical shifts, and we look for reflections. Cosine is the same, but we start at the amplitude, go down and come back up again. So you're still doing the same process, except when you go to graph it, you start at the amplitude. Then we got to tangent. Tangent was our bx minus c equals negative pi over 2 and positive pi over 2. Subtract the period, which is pi over b, add the period, which is pi over b. We got to cotangent, bx minus c equals 0 and equals pi. And then subtract the period, which is pi over b, add the period, which is pi over b. Cosecant, we're going to first graph sine of that function, and then every x-intercept is going to have an asymptote, and every peak is going to have a parabola pointing up. Every fall or every min is going to have a parabola pointing down. And then the last one, which is secant, that's the reciprocal of cosine. So we're going to graph cosine. Every x-intercept would be an asymptote, and then every max gets the parabola pointing up, and every min gets the parabola pointing down. Questions on anything related to any of the 6 curves? All right, so again, the homework for this is PDF. I already opened it, okay? That's due tomorrow. Make sure you are showing your work with these. A homework filled with a bunch of graphs with no points and no work is not going to get any credit. So you want to make sure you're practicing these graphs.